Let's start our second lecture on synchronous machine. Before we do that, let's see what we have done in the last class. In our last class, we said that a synchronous machine can be thought of a AC source connected to another AC source through an inductance. A simple way to represent it then is using a single phase circuit. Then we said that this equation can help us in finding the current. And finally, we end up with a problem here where we say that V1 is equal to this, V2 equal to this, and we are supposed to find the current in the circuit. Now let's first look at the solution to the problem. So this is how the problem is solved. I hope all of you can do that, and it is better if you use a calculator to do this. It is always advisable to use a calculator to solve this. Now why we are solving this numerical? The objective is that to understand how the power is flowing in the circuit. If you remember in last class, we said that we have assumed a direction here and said that if the result is positive, our direction is correct. If the result is negative, our direction is wrong. So this is direction of power flow. So after solving this equation, we will be finding the power, and from there we will understand in which direction the power is flowing. So for this we have to find the power from this equation. Now how to find a power? In an AC circuit, apparent power is given by S is equal to V into I conjugate. Now we need to understand it clearly why we need to find the conjugate of this variable I. Now this V and this I, these are complex number. So if these are complex number, this can be represented as V, magnitude of V at an angle theta 1 into magnitude of I at an angle theta 2 and then conjugate. Now when we take a conjugate of a complex number, what happens? The angle or the argument, the sign of this argument changes. That is, if it is positive, it will become negative. If it is negative, it will become positive. So we can write it like this. Let's see it diagrammatically what it indicates. I have a voltage. Let this be my reference with which we are measuring the angle. Let's say that this is my V1, which is at an angle of theta 1. That is, this angle is theta 1. Let's say that this is my I at an angle of theta 2. What does it mean? That this angle is theta 2. So when we find power, what we do, what we can easily remember is for active power. For active power, we can say that P is equal to V into I into cos of theta. Now what is this theta? For active power P, we can write it as V into I into cos of theta, and we all understand that this theta is the angle between V and I. So here if you look at this, if we take conjugate, P will be equal to V, magnitude of V into magnitude of I, okay, I'll write it as S, that will be more clear. S will be equal to V into I at an angle of theta 1 minus theta 2, and from there we can write P as magnitude of V into magnitude of I into cos of theta 1 minus theta 2. Now, if we don't take a conjugate, what we will get? We will get it as theta 1 plus theta 2. So we are not getting the difference of the angle between the voltage and current, but we are getting a summation which we don't want. So for that, always we have to take V into I conjugate for apparent power. What will be the reactive power from this? It will be V into I into sine of theta 1 minus theta 2. So this is nothing but the real part of the complex number, and this is the imaginary part of the complex number S. Real part of the complex number S and imaginary part of the complex number S. Okay. Now, why we did this? We did this to understand what is the direction of power flow in the circuit that we have previously discussed. In this circuit, we have assumed that the power is flowing from this source to this source. So after solving the numerical, we have to find what is the magnitude of this current, or what is whether the expression for power is positive or negative. After solving the numerical, what we get is that the value of I is I at an angle of theta. After solving the numerical in your assignment, you have got it 1.113 at an angle of minus 171 degree. So what is the value of V? Now if we have to find the power for this source, our V will be 1.2 at an angle of 30 degree. If we have to find the power for this, our V will be 1 at an angle of 30 degree. Let's first find the power for this source. Let's call it as source 1. For the source 1, apparent power S1 is equal to V at an angle theta into I at an angle of say theta 1, theta 2 conjugate. So what is V for this source? It is 1 at an angle of 30 degree into what is I? I is 1.113 at an angle of minus 171 degree into conjugate of this. So it will be 1.113 at an angle of 30 degree So the value of S1 here is 1.113 at an angle of 201 degrees. Now if we calculate power from this, active power is nothing but the real part of S. So that can be calculated as 1.113 into cos of 201 degrees. So if you calculate this, it will come to be minus 1.03. What will be the reactive power for this source? Q will be equal to imaginary part of S, that is 1.113 into sine of 201 degrees. So if you calculate this, it will come to be minus 0.398. Now we have calculated the active and reactive power that is supplied by source S1. let's look at the other source. We have calculated for this. Now we will similarly calculate for this source, that is S2. So how to do that? The apparent power of S2 will be equal to 1.2 at an angle of minus 30 degree into 1.113 at an angle of minus 171 conjugate. So this is 1.335 at an angle of 141 degree. So if you calculate active power from this, it will be real part of 1.335 at an angle of 141 degree, that is equal to minus 1.03, and Q will be equal to imaginary part of 1.335 at an angle of 141 degrees, that is equal to 0.84. Now till now we have calculated the apparent power of this one and the apparent power of this one. There is one more circuit element here, that is this inductance. For this one also we can calculate the apparent power. How to calculate the apparent power for this inductance? For this we have to calculate the voltage across the inductance. Now what is the voltage across the inductance? So I'll write it as S3. S3 is equal to, what is the voltage across the inductance? Voltage across the inductance is 1.2 at an angle of minus 30 degree minus 1 at an angle of 30 degree. This is the voltage across the inductance into the current flowing through the inductance. What is the current flowing through the inductance? It is 1.113 at an angle of minus 171 conjugate of this. If you calculate this, this will come to be 1.23 at an angle of 90 degree. So what is the real part of this power? P3. P3 is equal to real part of S3, that is 1.23 into cos of 90 degree, that is equal to 0. What is Q3? Q3 is imaginary part of S, that is 1.23 into sine of 90 degree, that is equal to 1.23. Now let's redraw the circuit once again. What was our circuit? Our circuit was, here we have 1 at an angle of 30, here we have 1.2 at an angle of minus 30, and here we have 1 at an angle of 90. This is a voltage, this is a voltage, this is an impedance. We have calculated the apparent power here, or I'll write like this: P here is equal to, what is the value of P that we have calculated for the first source? we have calculated P for the first source to be minus 1.03. What is the P for this source? I'll write it as P1, this as P2. P2 is again minus 1.03 and P3 is 0. Now while solving the circuit, we have taken an assumption that the power is flowing in this direction. And we got a result that P1 is negative and P2 is negative. So what does it mean? It means that in both the sources the power is flowing in the opposite direction. That is, for this source the actual direction of power flow is this, and for this source also the actual direction of power flow is this, and this one is not consuming any power. That's why the power that is supplied by this source is totally consumed by this source. Now let's look at Q. Let's draw this circuit once again. This is 1 at an angle of 30. This is 1 at an angle of 90. This is 1.2 at an angle of minus 30. If you look at our solution, you will find that for S1, the value of Q, which is S1 for our case, S1 is this one. So for this, this is Q for S1, minus 0.398, and for this one it is 0.84, and for this one it is 1.23. Again we have taken a direction of power flow like this. Now when we take direction of power flow, we have never mentioned that it is active power. It is both for active power as well as reactive power. Now you can see here the number is positive. It means that from this source reactive power is flowing in this direction. That is, Q is flowing like this. Here Q is negative. This is Q1, this is Q2, and this is Q3. For this source, reactive power is flowing. We have taken an assumption that it is flowing like this, and we got a negative result, which means that in actual circuit the reactive power is flowing in the opposite direction. That is, for this source the reactive power is flowing like this. So this is my Q1 and this is my Q2, which is 0.84. So both the sources are supplying reactive power, and if you add them up you will find that this is equal to 1.23, which means that this inductance is consuming the reactive power. So what we have understood, we have taken up an example to explain you how to find the direction of power flow. When we say power, we mean active as well as reactive in a AC circuit. Why we will need this? We will need this because in synchronous machine we will take up many examples when we have a AC source and a grid and we have to find how much power is flowing. So let's take another example. You solve it as an assignment and submit it in Google Classroom. Exactly the same problem, only with some difference in data. Find out what is the power at this source. what is the power at this source and what is the power at this source. When we say power, we mean active power and reactive power. So what you have to find, if we say it as source 1, this as source 2, and this as 3, then you have to find P1, you have to find Q1, you have to find P2, you have to find Q2, you have to find P3, and you have to find Q3. How you will understand whether your result is correct or not? The sum of power in the whole circuit should be 0. Similarly, the sum of Q in this circuit should be 0. That is, whatever Q is supplied by these two should be consumed by this. Whatever power is supplied by this should be consumed this, or vice versa. Submit it in the Google Classroom.